welcome back to my channel Cat by Nagendra. So in this video we are going to create this plumber block assembly design. Now let's create this part designs first. For that, first we are going to create this base part. So just I'll enter into here CATIA and I'll enter into here new part. Let me give here part name as base. Now to create this base, as you can see, we are having sectional front view and we are having here top view. So in section front view, we are having this inclined shape like this here, and again this entire shape we are having here. But if you see from top, only this rectangular section we are having. So whenever we are having this inclined or curve profiles, from where we are getting those, on the same we need to draw. So just we can create this shape, then we can make this pad of 46. Now let me adjust here toolbars properly according to our convenience. Now on the front plane, I'll go for sketch. So to create this shape, I'm considering this point as origin point. From here, we need one curve with radius of 24. So first let me start here with one circle. Dimension for this we are having here radius of 24 like this. Then at some height we are having here one horizontal, vertical. Let me create this entire shape here. Exactly not from this horizontal axis, little up with difference of 4 mm. Somewhere from here one horizontal, then one vertical, then one more horizontal like this, somewhere up to here, then again one horizontal, then one inclined line like this, one inclined line. So just we can make it here up to close, or else full only we can draw, then later we can make this mirror. Now let me select these things, only these lines, then we'll make mirror with reference to this. Just by using constraint, we'll make relation between this to this coincidence. So everything we can do mirror, but if you make mirror, as we know here, one more center line we'll get while making pad. So to remove that, I have not made only half section, full I have drawn. Then let's trim this unwanted elements like this. Then by using constraint, we will give dimension from this center point to this horizontal line. Vertically, we are having here 4. So this to this, we are having here 4. Then next dimension from this horizontal line to this up, we are having vertically 16. So for this, we are having dimension of 16. Then dimension from vertical line to vertical line 56. From this to this, we are having here 56. Then next we are having here this extra material. As you can see, this curvature dimension we are having 54 radius. So from center to this end, I'll make it here 54. Later we can remove unwanted elements. Then dimension for this height we are having here 14. So for this, mouse right click, we need vertical dimension of 14. Then next we are having here inclined angle of 106 degrees between this to this in this direction. We need here 106 degrees. Then dimension from end to end we are having here 208. Just we'll give all dimensions 208. Then from top to bottom we are having here 68. From top to bottom we are having here 68 like this. Just we can make it here exit workbench. Make this pad by using mirror extend. So total width we need here 46. So we'll make it here 46 by 2 as we are using mirror extend like this. So this is one method, or else just we can create only this base. Later with this curvature we can add material. But now we have added extra material. Now we are going to remove that extra material. So here we'll go for position sketch to make proper position, horizontal, vertical. Let's save. Okay. Now this curvature we want with radius of 54. So let me create here with center point arc somewhere from here like this. Dimension for this we are having radius of 54 like this. Just by using this project 3D elements, we will project this edge again here, again here. Why? Because we are going to remove material here. Then by using quick trim, just we will trim these unwanted elements. We need only this part like this. Same thing, we'll make it mirror with reference to this. Then exit workbench, make this pocket. We need to remove this material up to this edge. As you can see in isometric view, material should be removed up to this next element. We'll make it here up to next like this. Then same pocket will make it mirror with reference to this plane, and let's say okay. So let me edit that. It is going up to last. Just by double clicking on that, this height dimension we can give, or else we can use up to surface up to this surface. So here also we are not able to get. So let me give dimension. Total height 68 minus 14. So I'll keep it dimension. We need 68 minus 14 like this. So if you look from front, we are having this, and from top properly material is removed. So like this we can create this base part. Now all addition of material done. Then we will go for removal of material. Here one thing you can see, with height of 2 mm, with length of 195, material is removed, but here they have not given in hidden lines. So just we will consider this, and we will make here that too this pocket is not through all. Why? Because in isometric we are not able to see that. At center only some material removed. So that I will consider as total 46. This side we will leave 3 mm. This side we will leave 3 mm. Exactly at center 40 mm we will remove with this dimension. For that, on the front plane we'll go for sketch. Why? Because we need to remove material on both directions. Then just by using one center point rectangle with reference to vertical axis, I'll create one rectangle. By using constraint, relation between these two we need here coincidence. Height we are having here 2. Then length we are having here 195. Let's give the dimension 195. Exit workbench. Make this pocket. From center we are going to make removal of material on both sides. Total 40 we want. We will give 20. So properly 40 mm material will be removed like this. Then next we can go here with these pockets. So here also we are having one elongated hole with radius of 6 and with dimension of 8. So exactly on this support we can go for position sketch, make proper positioning. Then just we need one elongated hole exactly on this horizontal axis like this. Radius we need here 6. By using constraint, dimension for this we are having here 8. Then from this to this we are having 154. So let me select this and let me make mirror with reference to this. Then dimension between this point to this point we are having 154. So this to this point we are having dimension of 154. Just I'll go for exit workbench. We'll make pocket up to next. Like this, material will be removed. Then next we'll go here with this square plots. We are having here square of 28 exactly with the distance of this 78. Now just I'll go for sketch again here. We'll make proper position. Okay. We need one square. Let me create one square here. Same square will make mirror with reference to this. Dimension from this to this we are having 28. Again here also we need 28. Then dimension from center to center we are having 78. Let's give dimension between center to center 78. Exit workbench, make this pocket. So this pocket height we are having here, as you can see, we are drawing profile above this 2 mm. So total depth we need here for this pocket we are having 10 mm. So let's make here 10 mm this pocket. Let's check this. This is through all, and this we are having 10 mm. So we can make it here a dimension of depth 10. Then next we can go here with dress up features. So dress up features we are having here radius of 8 mm for these two curvatures. So fillet we want for this edge with radius of 8. Then next we are having here double lines. So here we need to specify chamfer or else fillet also we can apply here. So we'll go here with chamfer, but the chamfer dimension they have not given. We'll take our own dimensions here. So just I'll go for chamfer for all this edge. As you can see, all four should be applied. So again here, then we need here. Let's take some three. We will check. Then let me keep it here. Top view. We can see the shape like this. Then last we can go here with holes. So here holes we are having two with a diameter of 12, depth up to last. Then again one more hole here at some distance. Let's create this diameter 12 mm hole exactly on this surface. So here we want diameter of 12, depth up to next. Go for position. Whatever the position we made for square, same position we wanted. So just we will give dimension between this to this. We need here coincidence from this end to this point we are having here. So this to this dimension we are having here 78. We'll make it only of 78 by 2. Exit workbench. Let's save. Okay. Same we can make it mirror with reference to this like this. Then last one more hole we want with a diameter of 8 with a depth of 8 from this. So here we need depth of 8 mm. So here as we are having curvature we can't create hole from this support. So I am considering this as support. So total dimension from this to this curvature we are having 24 plus extra 4 28 plus extra depth we want total 36 depth I will give from here with a diameter of 8. One hole we want with reference to this face with diameter of 8, depth of 24. I hope you have understood this. 24 from here plus extra 4 28 plus extra depth of here 8 mm. So 28 plus 8 we need here depth of 36. Go for position. So we need exactly at center. This point to this origin will make it coincidence. Exit workbench. Let's say okay. Properly from there 8 mm depth will be there. So like this we can create this base block. Let's apply some color for this and let's save it like this. Then we can go for file, save, under assembly design, create new folder as. So this we are going to create plumber block. Open that folder, save it as base. Then just I'll close this. So next we will create this upper block. So similar to what we have created this base. So for this, so just I'll go for new part. So we are going to create here upper block. Okay. Now same to create this upper block. In front view we are having this curvature. In top view we are having here these different shapes. So just let me create this front view shape. Just we'll enter into front view. Then to create this shape, we'll consider this point as origin. From here we are having one curve radius of 24, one more with radius of 48. So let's create here two curves by using center point arc. Just one curve here, then one more curvature like this. By using constraint, dimension for this inner one we are having radius of 24. For the next one we are having radius of 48. Let's give that dimensions like this. Then next to that, exactly with end of this radius of 24 somewhere from here with a distance of 8, we need one horizontal vertical, then this step we wanted. Let's create somewhere from here just one horizontal line, then one vertical, then one more horizontal, then again one more vertical up to this curvature like this. Same shape will make mirror with reference to this. Then by using quick trim, let me trim these unwanted elements. So just we don't want all these things, we will trim that. Then by using constraint, dimension from origin point to horizontal line we are having 8. So this to this dimension height we are having 8. Then dimension from vertical line to vertical line we are having here 56. So this to this we need here 56. Next to that, this height we need 12 and at this height we need 16. So this height we need 16, then this height we need 12. Then overall dimension from starting to ending we are having 108. So let me give dimension from this to this. We need here 108. Exit workbench. Make this pad by using mirror extend. So same here also total width we are having 46. We will make it here 46 by 2 like this. So in front view this is the shape, but in top we need different shape. So here we need to remove this extra material with this shape with curvature radius of 17, and this extra part also we need to remove with radius of 54. So now we'll go for sketch here on the top. So I think we can do it with the fillet. Let me try with fillet here. 54 again. This width is different. We can't get that. We need to go here with pocket only. So just I'll use here proper position. Now some from center we need here radius of 54. Just from this center we'll create one curvature here like this. By using constraint we will give radius of 54. Then by using this project 3D elements, let's project this end line, again this horizontal line. By using quick trim, just we can trim this unwanted elements here. Then just I'll select this, we'll make it mirror with reference to this. So here we can't, why? Because it will be attached to that, again we can't remove material properly. So only we are taking opposite sides. So just I'll make it here up to next. Same thing will make mirror with reference to this like this. Then one more pocket also we need with this radius of 17. Again same on the top face. So we need one curvature with radius of 17 from this distance of 39. Let's create one curvature somewhere here like this. Dimension for this we are having radius of 17. Dimension from this center to center point we are having here 39 like this. Then just I'll elongate this. Just I will double click here. By holding the 10 point, I'll enlarge this. Then by using here project 3D elements, we will project this curvature. By using quick trim, we can trim this unwanted extra elements like this. Then same shape, we need one more that side. We'll make it mirror. Exit workbench, we'll make pocket up to next in reverse direction. So we need here upwards like this. Properly that material will be removed like this. Then next we can go here with dress up features. Same here we need chamfer. So just we will apply chamfer. For base plate we given 3 mm. Here also we will take 3 like this. Then two holes we are having here. So here just whatever the dimension we'll be having for this, same will be having here. So we are having diameter of 12. So let's create two holes with a diameter of 12. So we need one hole on this top. Or else directly we can take exactly center of the curvature. Why? Because this is the center point of the curvature. Exactly center of this curve from this face with a diameter of 12, depth we can make it up to next. Same hole we need one more. We will make mirror with reference to this. Like then next we are having here one counter bore hole. Normal hole diameter is 6, depth should be up to last. Then counter bore diameter we are having 8, counter bore depth we are having here 16. Now we need to create that hole from this curvature surface. Directly on curvature we can't create a hole. So in such cases we need one proper planar reference. For that we are going to create one reference plane. So we need dimension from origin to this point. So as we know, this is 8 mm, from here to here 16 again, or else exactly from this point we are having 48 height. Directly we can take one reference plane from top with a distance of 48. So if I keep it front view, you can see properly it is tangent to that surface. Just we can make it isometric. We need one hole with reference to this plane. Just normal hole diameter we are having here 6. Depth should be up to last. Gopher type we need here counter bore. Counter bore diameter is 8. Then depth is 16. It should be exactly from origin. We'll go for position sketch. We'll make it relation between this center point of the hole to. Here I am not able to select center point. So exit workbench. While making position, we will drag somewhere like this. Then if you go for position, we'll get that proper point selection. We'll make it here coincidence. Exit workbench. Let's say okay. So let's check counter bore hole. Yes. Then at end, you can just mouse right click on the plane. We can hide the plane. So like this, we can create this upper block. I hope you have understood this. Let me save here. Upper block where we have saved base. There only we are saving this. Let's save it. Then just if you want to apply some color, we can go for properties and we can apply some color. Just I'll save it again. Just next we'll go here with this center block. So for this, as you can see, all dimensions we are having with diameters. It means output shape is with circular shape. So directly we can create off section. We can make it here shaft. So for that, new part. So I'll consider this as center block. Center block. Just we'll go for sketch on this front plane. By using profile, we will create only this half section like this. Somewhere from here, one vertical, one horizontal, then one more step and one more step. Here, again, up to here. Or else full also we can do. Just we'll make it here only half like this. Then entire thing we will make it here mirror with reference to this. And to make it a closed profile, let me draw one center line here like this. Then by using constraint, dimension for this inner block we are having, as you can see, diameter we are having here 32. Let's give dimension from this to this 32. As we are creating only half section, I'll give only half dimension 16. Then horizontal dimension from this line to this line we are having here. So this to this gap of 28. So this one to this one we need here 28. Next to this 32, next for this we are having here diameter of, as you can see, so this is inside is 32, this is 44 and this is 48. So sorry, this is 44 by 2. Then this is 48 by 2. Then last one we are having 64. So 64 by 2. Then horizontally we are having first one is 28. Then this to this we are having 46. This to this we are having 46. Then next gap from this to this we are having 9 mm. So this gap we need only 9. So I hope you have understood this. Just exit workbench. We need to add material with rotation. We can go here with the shaft with reference to this y-axis, and let's say okay. So if we make mirror, this center line we will get extra. So if you don't want that, we need to create a straight single line. So after this addition of material, directly we are having here one center hole with a diameter of this 32. Depth should be up to last. One hole we want exactly center of this, diameter of 30, 32, diameter of 32 we need to create. So we need here diameter of 32, depth up to next like this. Then one more hole we are having here with, we are having one extra block with a diameter of 8 mm. So from here to here extra material should be added with 30. So this curvature to extra we need to add dimension of 30. So one thing we can do here, before doing this hole, just we can go for sketch on this top plane. One circle we will draw here with diameter of 8. We need here diameter of 8. Exit workbench. We will make this pad. So from center we need extra material of 30. Directly we can make it 30 here. Later we can go for hole exactly center of this from here with a diameter of 32. If we remove material properly, that extra material also will be removed. Then one more hole we want here with a diameter of 6. Depth should be up to last. One more hole center of this block from here with a diameter of 6. Depth up to last like this. So it should come throughout like this. So that is about this center block. So it's very simple part. Just I can go for properties. I'll change some color for this. Then just save it. Center block, save. Again I'll close this. Then next we'll go here with this bolt. So square head bolt we are having with 24 into 24. Material should be added of 8 mm. Just we will go here with bolt. We need to design bolt. On the top plane, I'll go for sketch. We will create one square 28 into 28. 24, sorry, 24 into 24. Exit workbench, make this pad. That pad height should be here 8 mm. Let's make this pad of 8. Upon that, we'll go for one more sketch. We'll draw one circle. Circle diameter we are having here 12. It should be extrude boss of 104 from top. So we are drawing circle here. We'll make 104 minus 8 mm. Circle diameter we need 12. Exit workbench. Make this pad of 104 minus 8. Why? Because already 8 we have made that extruded boss. Then next here we are having removal of material with this circle shape. So for that usually they'll specify with radius, but they have not given here. We will consider radius of 3. So here we need to remove material with rotation. So here we are not having any planar support. Why? Because material should be removed from these edges throughout like this. So for that, let me create one inclined plane here by using this angle normal to plane. With reference to this, z-axis as rotation axis. With reference to this plane, I'll make here 45 degrees inclination like this. So that we are able to create profile at these edges. So I'll go for sketch on this inclined plane. Then by using here project 3D elements, I'll project these two curves. Then by using corner, we'll apply fillet for this. I'll take with radius of 3. By using quick trim, just we can trim these unwanted elements. Exit workbench. We need to remove material here with rotation by using groove with reference to this Z axis, and let's say okay. Now properly that extra material will be removed here. So let me increase this fillet radius. Let me take some 5. Exit workbench. Properly it will be removed like this. Then this plane, just we can hide this. We will apply some color for this bolt and just we can save it. Just we'll save it as bolt. Then I'll close this. Then let's create this two nuts. So with hexagon of 26 length at circle radius of 12 mm with radius of 5, we need to remove material. So just I'll go for new part. We need here hexagonal nut. Here two nuts are there, one with 12 and one with 8. I'll take here hexagonal nut 12. Okay. On the top plane, we'll go for sketch. We need one hexagon exactly from horizon like this. By using constraint line to line, we are having here length of 26. Then it should be make pad of 12. So along with that, we can create this whole circle diameter of 12 also. Let's create one more circle here with a diameter of 12. Exit workbench. Make this pad. So total we need here 12. By using mid plane mirror extent, I'll do 12 by 2. We'll get 6 mm. Then we need to remove material with radius of 5 with rotation here. For that, as already we have discussed in before tutorials, on which plane we will be having here diagonal endpoints more length. On that plane we need to go for sketch. Then just by using project 3D elements, we can project these two edges. And by using corner, we need here radius of 5. By using quick trim, just we can trim this. Just we need to remove material with rotation by using groove with reference to this. Same groove we need downside, we can make it mirror with reference to this top plane. Or else in sketch itself, we can make it mirror. So let me go for properties and let me apply some color for this. Just save it. Then same similar to that, one more we are having here. Same with 26 only, with 12 only. Just we need to change this and we need to change this. So what I'll do is just I'll edit this. So in sketch, this radius we need only 3. Then in this pad, instead of making here 12, we need only 8. So I'll take it only 4. Here, instead of going for save, we'll go with save as. Go for save as. So here, hexagonal nut only 8. Let's save this. That's it. So like this, we can create all these parts related to this plumber block assembly. Next, we are going to see how to make this assembly design. Now, let's create this assembly design with whatever the parts we have created and we have saved earlier. So for that, first we'll start here with this base. Let me enter into here assembly design. To call existing part, we can go for existing component. Under this product, we need here base. Open that. So already we know that while creating an assembly design, one base part should be fixed. So let's make that fix by using this fix component like this. Then I'll go here with existing component with positioning. Click on product. We will call here now center block. The center block we want. Just I will move little up and I'll keep it somewhere here. Then by using coincidence constraint, we'll make relation between this axis to this small axis. Let's make this update like this. Then this entire block should be rotated and it should be settled down. For that, we can go here with manipulation. By using this last option, drag around axis, we will fix this axis. Let me rotate like this. Okay. Again, if we update, it will come straight to that. Then this central axis, it should be straight to this. So we'll make it again coincidence like this. Properly, it will go inside and it will fix there. Then if we check degrees of freedom for this block by using this, you can see there is no degrees of freedom. Then we can consider that this block is fixed properly. Next, we can call this upper block. So existing component with positioning, we need here upper block. Open that, keep it somewhere here. So here also directly we can go for coincidence between this hole, it should be straight to this hole. Then this hole center should be straight to this hole center. Then this face, the cylindrical face, just if we make update, it will come straight. Here, the cylindrical face should attach with the cylinder. So here we are dealing with surface to surface. In such condition, we can go for contact constraint between the cylinder profile to the cylinder profile. Okay, let's update that. Properly, it will fix there like this. Then next we can call this bolt and nuts. By using existing component, just we will call this bolt. Then just by using this, we'll make it somewhere here. Now, again by using coincidence, this bolt axis to this whole axis, it should get coincidence. Then this hexagon side face, it should attach with this side face. Okay, update. Then let me check that. Just I will go back to remove that. I'll update here. Then by using coincidence, this face to this inside face we can give. So this face, it should attach with this inside face in opposite direction. Okay. Then still if we check degrees of freedom for this bolt, here rotation will be present. Rotation is there with reference to this z-axis. To lock that rotation, we can go for this angle constraint. Any plane we can select with reference to z-axis. So this plane to this face will make it parallelism like this. Same similar to that, one more bolt we need this side. Again, I'll go for existing component. So I'll call one more bolt. I'll keep it somewhere here. Then by using coincidence constraint, this axis to this whole axis we need relation. Then this face to this face we need relation in opposite direction. Then by using angle constraint, this face to front face we can make it parallelism. Let's update it. Properly it will get settled there. Then end we are having here two bolts. So as you can see, first is 12 mm, next one is 8 mm. Existing component with positioning. First I'll call this 12 mm. Just I'll keep it somewhere here. Then by using coincidence constraint, first I'll give axis to axis. Then this face it should attach with this face. Then rotation will be present. By using angle constraint, this front face to front face, I'll make it parallelism. So assembly design is very simple once if you know how to apply this all constraints properly. Again I'll call the same part. We can use this define multi-instantiation or else again also we can call. So bolt 12, I'll keep it somewhere here. So if we have done these two holes with pattern, we can use here reuse pattern, but we made mirror. So again manually we need to apply all relations. So again this face to this face, then angle constraint between this face to this face, parallelism. Okay, update. Again existing component under product, we need nut 8. So let's make it here automatic naming. Why? Because we given there save as, so it is showing error with this name. So let's make it somewhere here. Again, same relations I'll apply. Axis to axis, then this face, it should attach with this face, then angle constraint, this face, it should attach with this face. Make it parallelism. Same relations will repeat here. Again, existing component with positioning here, not 8, close. We'll move somewhere here. Again, axis to axis, then this face, it should attach with this downside face. Then angle constraint, this face should attach with this face, make it parallelism and update. Like this, we can create this assembly design. So if you want, just we can change color for these two by using properties. We can go for graphic here. We will apply some different color for that both bolts. Like this. So at end, if you want to hide all constraints directly in specification tree, we can hide all these constraints. Then to hide all access systems, we can use Control F. Then here workbench, we need to go for part design. Then type, we need to go for access system. Search and select, just we can hide or show. Like this, we can do this Plummer block. I hope you have understood about this assembly. So if you really like this video, please like the video and please share to your friends to whom it will be useful. Thank you so much.